All right, so today I'm going to show how to create your first Calkit project so you can start working reproducibly in what I hope is the easiest and funnest way possible. All right, so we're starting off with a completely fresh Windows 11 machine here. Head over to calkit.org. This is the home page of the project. Click the Get Started link. This will take us to GitHub, to the installation section of the README. You can see we're going to need Git, Python, Docker installed. We're going to do Docker first, actually. Download the Docker installer. All right, so we're going to use all the recommended settings. We'll be doing that for basically everything we install here. All right, so we're done installing Docker. We got to close and restart the machine. Restart it after installing Docker. Let's make sure that Docker starts up properly. Let's go to the search bar and we'll just type Docker. Run Docker desktop. Docker is something that should be running in the background most of the time. So let's make sure that it starts up properly. Okay, so it's going to install WSL for us. WSL is the Windows subsystem for Linux. This will allow us to have essentially a Linux machine running inside of our Windows machine. Use recommended settings. All right, so it's starting the engine for the first time. We'll wait for the Docker engine to start. When we close that, it should stay running in the background. Let's open up PowerShell as an admin. So start typing PowerShell, and then we will right click, run as administrator, WSL, install, D. So we'll be able to run Ubuntu directly in Windows. And we'll actually install Calkit inside of Ubuntu instead of inside the Windows environment. We could install it in the Windows environment, but I typically recommend, if you're on Windows, it's a good idea to do things in WSL. All right, so we'll pick a username, pick a password. So now we have Ubuntu installed. Let's hop back to the installation instructions for Calkit. So let's see about Git. Let's just run git -- version. We're just going to do a quick git config. When you make your first commit, Git will complain and ask you to do this then, but let's just get out of the way now. Git config global user.name. Git config global user.email. All right, so we just configured Git. What about Python? I recommend using Miniforge for scientific applications. This will give you the Conda and Mamba package management system, which is typically a little bit nicer for scientific and engineering work. There are many Python distributions. You can basically get any of them to work, but this particular example we're going to go through today uses Conda to manage the environment for our project. So we're going to install one that has Conda in it. We'll go to this page of releases, go down to Miniforge 3, and we're going to download the x86 64 installer. I'm actually just going to copy the link here and go back to our Ubuntu terminal, and then let's see what we have in our home directory. Nothing. So I'm going to make directory downloads, then we go into the downloads directory, and then I'm going to run wget and then paste in that URL, and then it's just going to download that file in there. So we can ls here. We see we have Miniforge 3, and we're just going to run that. So we'll run it with bash mini, start typing it and press tab, and it'll tab complete for you. And there we go. So we'll enter the installer, press enter. Do you accept the license terms? Yes. It's going to tell us where it's going to install to. So it's going to be in our home directory. That all looks good. Okay, so what's it asking us here? You should update your shell profile to automatically initialize Conda. That is what we want to do. Let's type yes here, and it's telling us we're going to need to reinitialize the shell. All right, so we have Git, we have Python. Jump in here and actually see Python version. We can also run something like which Python, and you see that this is the Miniforge Python. So we have Git, we have Python, we have Docker. We should be good to go. We can just run this pip install calkit python command now, and then we'll have Calkit. Now let's see which Calkit. Okay, it's there. Calkit. Let's do help. Let's take a look at the version, Calkit -- version. All right, so we have 0.11.1. We're going to want to integrate with the Calkit cloud system. So let's go through this cloud integration step. Going to go to calkit.io and then sign in with GitHub. So we logged in with GitHub. Let's do the free one for now. It's going to be enough for what we need to do. So back to the cloud integration instructions, go to the settings page, and we're going to need to create an API token so we can use this with the CLI. Let's create a new token. again, the purpose is the API. We'll have it expire in 365 days. This is a secret. We're just going to copy it and put it into our config, but don't share this with anyone. Put it in a password manager, keep it safe. We're just going to run calkit config set token and then paste the token in. The next thing we're going to install that's not in the instructions because it's not a necessity is VS Code. VS Code is probably the most popular text code editor these days. There are alternatives, so you're not locked into this, but it's a pretty good starting point. So we should be all set up now. We could follow these quick start instructions and create a new project from the command line, but I'm going to do it from the web app. So let's go back to calkit.io and we'll create a new project. I'm just going to call it my first Calkit project. Give it a description. Pick a template. The default template is example basic. You can choose no template if you want and start with hardly anything in the repo. And you can choose if you want it to be public or not. In general, it's probably a good idea to make things public, but we are going to make this one private to start, since that's probably how most people will want to work, is start off with a private project and eventually make it public someday, bundle it up and archive it so you can cite it in your paper. So let's save. It's going to create us a new project, create a Git repo up on GitHub, and we can see our project homepage on calkit.io. So the homepage has the description of our project. It's got a basic README with nothing in it. It's got a to-do list, which is linked to GitHub issues, and it's got this questions field. You'll see where those end up later, but let's add one. Okay, now our project has a question to answer, which research projects probably should. Up here in the title, you can see that there's a link to the GitHub repo. Next thing we're going to do is just clone this project so we can work on it locally. So let's go to the GitHub page. Let's clone this. So if you go to this code button here up on GitHub, clone, we're going to clone with HTTPS. So copy that to clipboard, go back to our Ubuntu terminal, and then I'm going to make a directory just for Calkit projects. Let's go in there. We're going to clone it with Calkit instead of Git, but the syntax is the same. When we do it this way, it's automatically going to set up the authentication with the Calkit cloud to use it as a DVC remote to store some of our larger data files that we want to keep out of Git and some of the products of our pipeline. So let's clone it, and we're going to need to put in our username and password. So this is a problem. If you're on Linux, Git will probably tell you that you should be using a different way of authentication. You have three options here. We're going to use SSH, but you can see GitHub is telling us we don't have a public key set up. So let's follow this link and add a new SSH key. We'll call this one WSL. We're going to need to look up the documentation. GitHub add SSH key. All right, so the first link, not very useful. Thanks, Bing. But this how to add an SSH key in GitHub section seems right. Let's open up an Ubuntu terminal. We're going to run this SSH keygen command to generate a key. We have to replace this with our email. We're going to accept the defaults here, so it's going to live in the .ssh folder. I'm going to use no passphrase for this, assuming that this is a secure machine. Okay, so we have a key generated. Now what's the next step? We're going to want to make sure that the SSH agent is running in the background. So we can copy that command. Now we're going to want to add the key that we just created. Now we need to copy it to clipboard. We're on Linux, so we can run this command. This is going to print this with the cat application. Copy this, and then head back to GitHub in the add new SSH key and just paste it in there. Okay, so we have an SSH key. We should be able to then use our SSH URL to clone. So we're just going to run calkit clone and then put in the URL, the SSH URL. Okay, so we're going to want to say yes here because we just created that key. So it cloned the project, and since we created this from a template, it's trying to pull some artifacts that don't exist since it's a new project. We can ignore this error message. So let's move into that directory. So let's cd my first Calkit project. Again, tab complete after you start typing it. And we're going to launch VS Code in here. So let's just run code dot means the current location. And this is going to pull up VS Code in our project directory so we can start working on it. Let's allow WSL in our list of allowed hosts. Trust our Calkit folder because we're going to be managing that. We get a message here asking if we want to open in dev containers. This is a reasonable option. It's not necessarily necessarily required. I'm going to dismiss this for now, but you could try doing this. You can also open this dev container configuration created by the template in GitHub code spaces, so you can work on this up on the web without needing to do it on your local machine. All right, so let's just take a look at the structure of the project to start. Important files to note. So we have our Calkit YAML file. All of the project metadata goes in here. We have data sets created as part of the project. We have figures, publications, environments. So we have two different environments. We have a Conda environment and we have a Docker environment. The Conda environment is used to do data processing and plotting. It's defined by the environment.yml file. And the tech environment is a Docker environment that uses the tech live latest-full image. And this is what we're going to use to run LaTeX to build our paper. And we see the question that we added is down here. Now, this file can be edited manually or it can be updated with the CLI. Some other important files in here. So we have our environment.yaml file. This is a very basic Conda environment specification, Python, Pandas, Matplotlib, and NumPy. These should probably have more specific versions, maybe greater than or equals specifications. But we always have this environment-lock file, which will be generated if the environment needs to be rebuilt on a certain machine to run the pipeline, which we'll talk about in a second. So this gets all of your exact versions in here. So if you ever need to go back and say, like, what version really was run the last time I ran the pipeline successfully, it will be in this environment lock file. We have the DVC YAML file. Now this defines the pipeline for the project. So the main thing that produces all of the artifacts, basically just all the steps that need to run to produce the outputs of the project. This example project has a data set, it has a figure that gets produced, and it has a publication. And so we have 3 stages in the pipeline. The first one is to collect the data, and we can see the command is calkit runenv in the Py environment. We run this script called collect data. In this pipeline, we can define dependencies for each of the stages. So what this means is that DVC should track the content of these dependencies. And if they change, it means that this stage has become invalidated and it needs to be rerun. We can define outputs. These are the things that are going to end up getting tracked in our DVC section of the repository and will be sent up to the Calkit Cloud DVC remote. And you can set up dependencies between the stages by using the output of one as a dependency for the next. So we see we have the output from collect data being declared as a dependency for plot voltage. So that means, let's say we change how this data is collected, this file actually changes, we will automatically rerun plot voltage. And similarly, the paper depends on the figures folder and the paper manuscript file. So if our figure changes, the paper is going to get rebuilt automatically. So essentially, you run this pipeline with a single command, and that's all you need to do. You don't need to remember things like, oh, I need to run this Python script first, and then I run this makefile, and then I run this bash command. It's all one thing. So let's show running that now. Going to pull up a terminal. You can actually use control backtick. It's going to pull up a PowerShell terminal by default, but we want to run this in WSL. Let's select the default profile here to use WSL. Okay, it's got a recommended install extension, so let's install it. And it's going to recommend us to reopen this in WSL, so let's do so. We're going to, again, dismiss the notification for running in a dev container. Let's execute calkit status first. This is similar to git status, except it shows us more things. So it shows us the status of git, it shows us the status of the DVC data, and it shows us the status of the pipeline. So there's a lot of stuff that's not here because we haven't ever run this project. So let's just do calkit run. You should be able to execute calkit run at any time. I'll show that in a second. So this is the first time the pipeline's ever been run. Calkit is going to notice that the Python environment doesn't exist on this machine, so it's going to create it for us automatically. This will only need to happen once, but Calkit is going to check that this environment matches the spec in environment.yaml. In this case, the environment didn't exist yet, so it, of course, didn't match, but maybe one of your collaborators adds a dependency, and then you try to rerun this. The pipeline will rerun, and the environment will be recreated with the appropriate dependencies. So again, all you got to do is run calkit run, and the whole project gets reproduced. All right, so environment's getting created. It's running the next stage now, plot voltage, and it looks like we actually had a failure here. So let's check out this link. All right, we are running. We had to make sure that our user in Ubuntu had permissions to run Docker containers. This Tech Live image is kind of big, so this is going to take a little while to download. But the nice thing is once we have it, it's going to be sitting on our machine. We'll never need to download it again. Now the paper is building. All right, the pipeline ran. We can try to run it again, and we'll see that all the stages were skipped since DVC has determined none of the dependencies change for any of the stages. So we're good to go. Now, if we run Calkit status again, we can see there's going to be a bunch of changes to our project that haven't been saved or synced. We have the DVC lock file changed. We have the environment lock file changed. We have some new data files in DVC. So these are our artifacts from our pipeline. And we want to make sure that these are backed up in the cloud. So we should make a commit. I'm going to go ahead and do this with Calkit commit, and then -A to use all changes, and then M to say I'm putting in a message here, and I'm going to use run pipeline as the message. So let's take a look at status again, and we can see we made a commit, but we haven't actually pushed anything up to the cloud. Let's run Calkit push. That will send things up to GitHub and send things to the Calkit cloud DVC remote. So everything in this project is now backed up. If we go back to our project on calkit.io, we can jump in and take a look at, for example, the datasets section of the project. We can see we have a dataset there. We can look at our figures. This is the figure that we just generated. We can take a look at the publications. This is the paper that we just built. Now let's go back and see what happens when we start changing some of the files in the project. So we can kind of see the benefit of having a pipeline set up. Let's change how we plot this data. We're getting these linting errors here. You can click down here in the bottom right and select the interpreter. Calkit example basic is the name of the environment that we created. So let's set that as the interpreter, and that should have our dependencies installed. So open this back up. Okay, what can we change about it? Let's add a Y label to it. Set Y label, let's say voltage. All right, so we updated our script. Now let's see what the output of Calkit status is. We have a modified script in the Git section, and we then have our plot voltage stage needs to be rerun. So we have a modified dependency. So if we run Calkit run again, collect data did not need to be rerun. That gets skipped automatically. The plot voltage stage is getting rerun. And you'll notice that our paper is now getting rebuilt. We can see in the sidebar that these have all been modified. And let's use the LaTeX Workshop internal viewer, take a look at the paper, and we see that the Y label is now present in here. We can Calkit run again, and nothing will have changed. Everything is up to date. Now, instead of doing commit and push in 2 steps, there's actually a save command. So we can do something like Calkit save am add Y label to figure. It's going to save, it's going to push our files up. So if we go back to our project page, go check out our publication again. Let's go look at the figure. The publication is updated. It has the voltage in there. All right, so what else can you do? We can modify existing stages, but we can also create new ones. So what if you want a second plot? So let's just copy and paste this one. We can call it plot voltage 2. We'll create a new script for that. We'll have it depend on the data, and we'll have it produce a plot called voltage time series 2. Let's copy and paste this script. Let's rename this. And I don't know, let's say that the color equals red. If we go into the Calkit YAML file, we can also denote that that file is going to be a figure. So we can copy and paste this figure, put in the appropriate path, and then the stage is plot voltage 2. Let's just Calkit run here. Oh, looks like we have an error. Looks like there's probably something wrong with the script. Voltage time series 2. So that's kind of nice. Even though we had originally written this script and it overwrote our first figure, DVC actually made sure that the last version that was created was checked back out again. So even though we messed something up, things are now okay. Pipeline is rerun. We have our red plot. We can go and insert this into the publication as well. So let's go into paper and let's put in the voltage time series -2 figure. Okay, so we need to update our dependencies for the paper. Oh, actually we don't need to update it because the entire figures folder is labeled as a dependency. So instead of labeling each individual file, it's that folder. So that's kind of nice. We rerun this pipeline it's going to have to rebuild the paper because we just changed the paper.tex file. So we take a look at paper PDF. We can see we have the blue figure, we have the red figure. Now let's make sure we get these changes up to the cloud. Calkit status. This is going to be a little bit different because we have a totally new file. We don't just have modified files. We have an untracked file here. So we need to actually git add this because a typical save command is not going to include that. So let's git add scripts, plot voltage 2, and then let's do Calkit save -am add new figure. Head back to the project page, reload the publication, and we have a blue figure, we have a red figure. We can see on the figures page now we have 2 figures. Now, what are the next steps here? The next steps are really to just iterate on the pipeline. Add things, change things. Since the data is already collected, maybe there's a data processing step that needs to be done here to compute statistics, something like that. But essentially, it's just build your pipeline. Set this pipeline up properly, keep running it, keep track of the artifacts, and make sure to make commits and push them up to the cloud, and everything will be all backed up. All right, I hope that was helpful. Let me know if you try this out and you run into any trouble. Send me a message, leave a comment below, and I'll try to help you work it out.